P-value is the smallest significance level at which the null hypothesis could be rejected. It can also be interpreted as the probability of observing a value as large as the t-statistic if the null hypothesis is true. For instance, if we obtain a t-statistic of 2 in a regression with 100 degrees of freedom, the corresponding p-value will be 0.024. It means we observe a t-statistic as large as 2 only 2.4% of the time if the null hypothesis is true. The p-value represents the area to the right of the t-statistic in a t-distribution. The probability of observing a t-statistic of 2 is only 2.4% if the true value is 0. However, we obtain that extreme t-statistic from our sample, which implies that the true value of the parameter is highly unlikely to be 0. Our sample gives strong evidence that the null hypothesis is not true. Therefore, we can reject the null hypothesis that beta equals 0 at a significance level as small as 2.4%. A small p-value is evidence that we can reject the null hypothesis. A two-sided alternative case is similar. The p-value for a t-statistic of 2 against a two-sided alternative with 100 degrees of freedom is 0.048. It is the shaded area of the graph. It indicates that we can reject the null hypothesis at a significance level as small as 4.8%. In other words, we can reject the null hypothesis at the 5% significance level, but cannot reject the null hypothesis at the 1% level. The p-value is twice in the 2-tail t-test as in the 1-tail t-test for the same model. All other things equal, it is more difficult to reject the null hypothesis in a 2-tail t-test than in a 1-tail t-test. We usually perform a 2-tail t-test after OLS regression.